Black holes are already one of the biggest mysteries we face in the universe, but did you know that they actually changed the definition of time itself? Let's talk about that. Now, in order to understand this concept, first you're going to need to know about a little thing called space-time. Through his theory of general relativity, Einstein found that space and time are woven in a continuum we call space-time. The basic idea of this is that events that occur at one time to one observer can occur at another time to another observer. Let's say that you're looking at a black hole from somewhere on Earth. The circular object is orbiting around the black hole. The clock for the object runs slower relative to your clock. Essentially, 3 months for the object might be 3 days to you. This is because of something called gravitational time dilation. According to Einstein's general theory of relativity, the closer your clock is to a large gravitational field, the slower your clock will be. Since black holes have a massive gravitational pull, clocks on Earth may seem to run a bit faster than clocks that are closer to black holes. Now let's say that your friend, we'll call him Bob, is hurtling towards the black hole. You and the object both see Bob moving, but you see him moving at a different speed. However, things change when he crosses the edge of the black hole, known as the event horizon. To you, or the object, or anyone outside of the edge of the black hole, Bob just stopped moving. But he knows that he crossed the event horizon. How is this possible? How does everyone outside the black hole, regardless of their time perception, say that Bob has stopped? Well, the general idea is that events that cross the event horizon of the black hole do not have a set time in which they happen. No matter how long goes outside the event horizon wait, Bob would stay in the same place in their vision because, according to outside observers, the event of Bob crossing the black hole did not happen at all. Let's look at the math behind this. The equation for the flat space-time interval is as follows. Different observers may say that an event takes place at different distances or different times. However, they both see the same space-time interval. When black holes are involved, the equation becomes a bit more complicated. We end up with this. Note that this does not include orbital motion, which is a bit more complicated. RS represents the radius of the event horizon, and R is the distance from the black hole to your position. The closer an object gets to the event horizon, when RS is slightly bigger than RS, the brackets describe how space-time warps the closer you get to a black hole. When you reach the point where you enter a black hole and R becomes smaller than RS, then space acts like time and time acts like space. Space-time itself becomes warped. Wow, it's crazy how people can have different perceptions of time based on their location. It's even crazier to think that something like a black hole can warp time itself. Hopefully you learned as much as I did. Black holes really are some of the most interesting things in our universe.